Hi everyone, and welcome back to the final episode in the Python for Absolute Beginners series. I hope you've been able to learn a lot during this series, and if you've made it this far, I really commend you, because learning programming from zero can be pretty difficult. In the last couple of videos, we've covered pretty much all the basics that you'll need to know to get started in Python. Each of the videos was reserved for one or more core concepts, but there's a couple of things here and there that didn't fit neatly into the core concepts that are still really important to know. I want to take this video to cover concepts that may have been overlooked in previous videos and reiterate some key concepts that will definitely help you out. At the end, I'm going to go over how you can keep moving forward in Python and what your next couple of steps should be. I want to start off by reiterating how to use indentation in Python. I've gone over it quite a bit in the previous videos, but I want to cover it so we're all on the same page here. Writing colons and indenting is how Python knows when you're inside of a function, loop, conditional statement, etc. And it's probably the most important syntax thing to pay attention to when you're writing Python code. The best practice for indentation is to just use the tab character once to tab over. Indentation will cause errors in your program if it's not done correctly. Just remember, anytime we want to get inside of a block of code, like inside of a function, if statement, for loop, class, or whatever it may be, you will always need to indent. Let's say I try and write a for loop something like this. Let's say for I in range 0 to 10. And I type a colon, except in this line I don't indent, and I'm just going to print out I. If I try and run this, it might take a second, I'm going to get an error because I didn't indent after putting a colon. And just give it a second more. And there we go. So you see there's an error here because I didn't indent, and it specifically says expected an indented block. And if I were to do something else, let's say I were to take this colon away and I were to indent, I would also get an error because I need both the colon and the indentation. So the golden rule is that colons and indentation go hand in hand. So after you have a colon, you must indent. And to get inside of any block like a for statement, you need to indent as well. So now if I run this, you'll see it prints out correctly. Where you have to start really paying attention is when you're multiple levels of indentation in. So let's delete this. I'm going to clear this output here. Oops. And let's say we have a function. Let's say def my function. And inside of this function, I want to do a for loop. So let's write for I in range 0 to 10. Now inside of this for loop, I want to have a conditional. So I'm going to write if I greater than 5. Then inside this, I want to print something else like this. Let's just print out I. So now I have 1, 2, 3 levels of indentation going on. So if I write at this first level, I'm writing inside the function. If I'm writing at this level, I'm writing inside the for loop. And if I write at this level, I'm writing inside the if statement. So just always try and be mindful of how many levels of indentation you have. And again, indentation is super important, and bad indentation could cause you to be troubleshooting bugs for long periods of time if you don't know what you're looking for. Speaking of troubleshooting bugs, I want to talk about that next. There is absolutely no avoiding errors and bugs in your program. No matter how skilled you are, you're always going to run into problems. Even programming experts run into errors all the time. What makes a good programmer is finding out how to efficiently solve these bugs. If you type something into your code editor that isn't valid Python code, or you just try and do something funky, the computer is going to complain and throw an error message. So for instance, let's just delete all this, and I'm just going to write something like, let's say print z. Now if I run this, I'm going to say, the error is going to say name z is not defined, and that's because we never ever defined a variable named z. So how do we solve this here? If you're a mediocre programmer, you'll sit there and try to figure out the error for yourself. However, if you're an amazing programmer, what you'll do is take this error, you're going to go ahead and copy it, go to the next tab, paste it like this, and you'll be introduced to this magical site called Stack Overflow. Stack Overflow is a site that allows programmers to ask literally any question about programming, and other programmers can answer that question. If you're having an error or problem with your code, there's a 99.9% chance that someone else has had that exact same problem and the question has been asked and answered on this website. As a programmer, Stack Overflow is going to be your absolute best friend, so get used to visiting it. It's so popular, in fact, that if I actually go back to Collaboratory and I have this error, you'll see there's a whole button underneath this error design that literally just says Search Stack Overflow. A lot of the other editors have something similar that will link you to the Stack Overflow to explore any errors that you're getting. But what happens when your code is not running as expected, but you're not getting any errors? Of course, you could search it on Stack Overflow because Stack Overflow doesn't just include errors, but many times you'll need to reread through your code and evaluate what's actually happening. So let's delete this here. And let's say we have a function, let's call it double number. And we're just going to give it one argument, number, and the goal of this function is to return double of whatever the number is that we pass in. So in here, let's just write 2 times number. Then outside of this, I want to make a variable, let's just call it x, and I'm going to set it to equal to double number 4. Well, if we double the number 4, that should be equal to 8, which means x should be equal to 8, right? But if I go ahead and write print x, you'll see that it prints out none. So what's actually happening here? Moments like these can be confusing because you're not getting an error in your code, but something is obviously going wrong. And so we look at what our code is doing and realize, oh hey, in this line, we're not actually specifying a return value in this function, and we forgot the return keyword. So now let's just write return, and now if we run this code, you'll see it'll no longer say none, and x will now be equal to 8. Computers don't really ever make mistakes when it comes to software because computers only do exactly as they're told. If there is an error in your code and your code isn't doing what you want, the mistake is from the programmer, not the computer. So as tempting as it may be to say, wow, this computer is stupid and doesn't understand what I'm trying to do, remember that a computer is only as smart as the programmer. In regards to getting errors, you just have to adopt the mindset that, oh, this means I did something wrong, not the computer. Something I talked about in episode 2 and episode 6 was naming conventions. So by naming conventions, I mean how we typically name variables, functions, and classes. So recall that to name any of these, we cannot have any spaces, we cannot have any special characters besides underscore, and we cannot start these names with a number. A few examples of perfectly correct names would be my variable, my function, variable 1, variable 2, and so forth. In terms of style, it is mostly up to you how you want to write names, but your name should always be relevant to what you're trying to do. So if you're capturing user input and storing it in a variable, you should probably call the variable user input or something that can tell you what it means. In a lot of the examples throughout these videos, I used x or my variable or my function or super generic names like those to name variables. But in reality, those names don't indicate what the variable actually does, so try and stay away from those super generic names. We also went over 2 styles for naming variables, camel case and snake case. So camel case is when you make the first letter of the variable or function lowercase, and then every word after that starts with uppercase. So you're basically separating words by capitalization. So an example of some camel case variable names would be my variable, user input, or big variable, or something like that. Snake case is when instead of separating by capitalization, you separate all words by underscores and everything in the name is lowercase. So the exact equivalent variables in snake case would be my underscore variable, user underscore input, and big underscore variable. Either one is fine, but some people prefer one or the other, so it's good to know both styles. These rules apply to functions and variables, but classes are a tiny bit different, so I'll make this note down here. It's good practice to always capitalize, the first letter of a class. And this is so that as programmers, we can differentiate a class from other data types. So examples of class names would be car, dog, animal, and something like that, where we're just capitalizing the first letter. So everything else, like variables, functions, and so forth, should pretty much always start with a lowercase letter, while classes will always start with an uppercase letter. Another thing that I wanted to cover that I think is super important is methods that are associated with strings and lists. So methods are basically like functions, except we always use them with a string or list or some other data type, and we can use them by using the dot operator. So remember when we used append, remove, pop, and those kinds of operations when working with lists? Well, those are called methods, specifically list methods. So to use methods, we'll always have a variable that's a list or a string. So let's make one. Let's just say my list equals 1, 2, 3, 4, 5. Then to use methods, we'll type the variable name, like my list, the dot, and then whatever method we want to call. So let's say we want to call the append method, we would just do mylist.append, and then we'd fill in whatever we want here. So let's say 6. Python has a ton of built-in methods, so I'll go over a few with lists first that we've already learned. For all these examples, we'll just use this mylist variable, but obviously this name can be whatever we want. So to add an element to the end of a list, we'll use this .append method that we've already written here. So we entered 6 inside the parentheses, so that means we should add a 6 to the end of my list. So let's actually print out my list here, and you'll see if we print it, there is now a 6 at the very end. To remove an element from the very end of a list, we would do something like .pop. So after we've added the 6, let's do mylist.pop. And now this should actually remove the 6 that we just added. So you'll see if we print it, it's just back to 1, 2, 3, 4, 5. To clear all the elements of a list, we can use mylist.clear. And now if we run it, you'll see the list is completely empty. To copy all the elements of a list, we can use something like mylist.copy. So the list of methods goes on and on and on, and I'll link a page in the description where you can see all these different built-in list methods. You do not need to know all these by heart because honestly you can just look them up if you need them, but knowing them might help you out in the long run. Strings have these same methods too, and you can use methods with them just like we can with lists. So let's clear all this out here. I'm going to clear the output, and let's make a new string. We'll just call it mystring, and I'll name it after myself, so I'll just name it Austin. So let's go over some of these methods that we can do with this string. And the main difference between string and list methods that is super important is that string methods will not change the original string at all. So if I want to do anything with string methods, I need to make a new variable from it. Let me show you what I mean by that. So there's a string method called lower that puts all the letters of a string into lowercase. So if I call mystring.lower like this, and then I try and print out my string, we'll see if we run it, notice how there is still a capital A in the front and not all the letters are lowercase. This is because string methods do not modify the original string at all. If I want to apply this method, I need to make a new variable to actually see it. So let's actually write my second string instead of equal to mystring.lower. And then here we'll print out my second string. And then now if we run it, you'll see now all the letters are lowercase because it has actually applied the .lower method. Let me now show you a couple of other string methods. So similar to lower, we can also use upper to make a string entirely uppercase. So if I replace this .lower method with upper and I print out my second string, you'll see that Austin is now all capitalized. There is also a function that checks if a string is entirely uppercase or not, and it's simply called isUpper. So isUpper will basically return true if the entire string is all uppercase, and it'll return false if the entire string is not uppercase. So in here, I'm going to write my second string .isUpper, and because we've already capitalized this string here, this should return true. So if we print it out, you'll see it prints out true. Another useful thing that you can do with lists and strings is called slicing. So slicing allows you to only look at certain parts of strings or lists. To slice a list, we would use square brackets that you should hopefully now be familiar with. So I'm going to delete this and make all this room up here free. I'm going to make a new list, call it my list. I'm going to set it equal to 2, 4, 6, 8, and 10. And let's make a new variable. Let's call it my slice list. And to slice, we're going to use the square brackets and some slicing operator, which we indicate by a colon. And I'll show you what I mean. Let's say we want to get this slice list to just grab 2, 4, and 6 from this original mylist variable. To do that, we would write mylist square brackets 0:3. Now this is basically saying to grab the indexes of my list from 0 to 3, but not including 3. This ending index here after the colon won't be included in the slice, meaning we're really just grabbing indexes 0, 1, and 2. So now if we go and print out my slice list, you'll see that it prints out 2, 4, and 6. What if I wanted to grab 2, 4, 6, and 8? Then we would just change this 3 to a 4 here because we're grabbing indexes 0, 1, 2, and 3 now, which is just 2, 4, 6, and 8. What if I wanted to just grab 6, 8, and 10? I could do a similar thing, except I want to start with index 2 because that's where index 6 is. So let's do 2, and then we want to grab indexes 2, 3, and 4, so we'll have to have this one as a 5 here. And now if we run it, you'll see it prints out 6, 8, and 10. One neat thing is that you don't actually need numbers on both sides of the colon if you don't want. So let's say I wanted to grab everything from index 1 onwards. I could just write it like this. I would write 1, and it'll print everything out from index 1 all the way to the end of the list. So you see it prints out 4, 6, 8, and 10. If I wanted to do index 2 and onwards, I could just replace this 1 with a 2, and if I print it out, you'll see it prints out just 6, 8, and 10. So there's a lot of different ways you can do slicing with this. If I wanted to grab everything up until a certain index, I could do the opposite of this. So if I wanted everything up to index 4, I would write :4, because this is everything up to index 4, but not including 4. So if I actually print this out, it just prints out 2, 4, 6, and 8 because it's grabbing indexes 0, 1, 2, and 3. If I wanted to print everything up to index 2, but not including index 2, I would just write :2 like this, and you'll see it just prints out 2 and 4. So basically, if you write a number before the colon like this, let's say 2 colon, and you print that out, it'll grab everything from that index until the end. If you write just a number after the colon, it'll grab everything up until that index, but not actually including that index, so it would just print out 2 and 4. It's certainly not essential to know this, but it's a useful trick if you ever need to mess around with or manipulate some list, and you can do this exact same slice operation on strings as well. The reason I wanted to cover all these topics with you guys is to drive home some key concepts and some other useful tools that might help you out when you're coding in Python. I want to take the rest of this video now to talk about how you can move forward in Python and what your next couple of steps could be. Throughout these videos, I've taught you essentially all the key topics that you'll need to know as a beginner in Python. But if I just gave you all the tools necessary to build something, what good are they if you don't actually know what to build? So the most important thing moving forward with Python is actually building your own programs and working on your own projects. This is by far the best way to apply what you've learned, which in turn helps you learn so much more when you actually get some practical experience. Programming projects are also showcased to potential employers when you're looking for programming jobs. Employers want to look at what projects you've done because those projects help them gauge what kind of programmer you are. So the question is, moving forward, what kind of project should I work on? And here's where I tell you. The type of project you do should be dependent on what interests you. Are you interested in machine learning and data science? Grab a free dataset off a site like Kaggle.com where there are countless datasets over any possible topic. Then maybe take a look at the Pandas library for Python that can help you out with all different types of datasets. Hop into a Google Colab notebook and start coding. Look up tutorials if you need to, Google as many Stack Overflow questions as you need, but just get started. What about if you're interested in making games in Python? You should check out Pygame, which is a simple Python library that can make some fun little interactive mini games through Python programming. Maybe you want to make a Hangman game or Connect 4 or Checkers or some basic game like that. Look up some videos on how to use Pygame, hop into a Python editing environment, and get started. What about if you're interested in using Python for databases and web development? Check out MongoDB, which is a free-to-use database that can be accessed using Python. Read some of their tutorials, hop into an editing environment, and get started messing around with some of the code. No matter what project you want to do, the biggest and most important rule with this is to just get started. Even if you don't know what you're doing, just try to get started and look up help when you need it. If you get stuck in the learning phase where you're just endlessly watching YouTube videos all day but not actually coding anything, you're going to learn practically nothing about Python. Real programming expertise comes from working on your own projects and actually doing it. Surprisingly, actually coding is how you become a good programmer, not by watching 100 YouTube videos and not coding at all. If you're completely lost on where to start, I've compiled a list here for you with a ton of different project ideas. Just pick one of these that interest you and see what you can do. There's a few simple game ideas like a number guessing game, hangman, dice rolling, rock, paper, scissors, tic-tac-toe, and so forth. If you want to get more advanced with your games, you can build something like the snake game or something like Connect 4. And another popular project among intermediate programmers is building a calculator app. If building bots interest you, you can try making a Discord bot or a Reddit bot in Python or something like that. And there's a couple of data science things too, which are pretty cool. You could analyze your own Amazon spending habits using Python. You can analyze your Netflix watching habits. You can analyze some survey results, maybe analyze some salaries of different jobs, and so forth. In future videos, I may go through some of these project ideas to show you how I might go about building them. I guarantee you there are tutorials for every one of these projects that I've mentioned here that you can watch if you need a bit of a boost in getting started. Just remember that to get better, you should actually be coding to get some real-life practical experience. I really hope you've enjoyed this Python for Absolute Beginner series, and I hope that I've been able to help you out in getting started with your Python programming journey. Stay consistent with it and keep working hard, and I'll promise you'll become proficient. Becoming a programmer isn't easy, but you absolutely do not have to be a genius or even very smart to become one. Keep working hard at it and you will see how significantly you're going to improve over time, even if you're just learning one tiny thing each day. You're going to have roadblocks and problems along the way, but every time you get past one of those, you're that much better at programming because you learned something new. I believe in you and you should believe in yourself too. You can do whatever you set your mind to, and learning programming is no different. On that note, I'll leave you to start your journey, and hopefully I'll see you again in my future videos. Take care.